All right, we have our regular scheduled speaker here for the 10:30 on the moon lava tube stimulations. This is Mike Dunn. Let's give him a warm welcome.
Thank you, everybody. For those of you who don't know me, I'm usually the crusty old guy in the back of the picture somewhere in Antarctica or down below the surface of the sea with the grizzly beard and the ice axe in one hand and maybe the regular Edgar in the other, rolling my eyes back at the scientists or sticking the thermometers at the penguins or tagging the leopard seals. So this morning you're going to get a little bit different view, the view from our side, which is the guys that are out there in the field that are actually probably at some point in time going to have to design, develop, maintain, and eventually staff the habitats that could potentially eventually go on the moon and Mars. So with that said, what I'm going to talk about this morning is our efforts relative to taking a look at lava tubes as potential alternatives for placing those types of habitats in the future. Well, there's obviously a number of potential advantages to using lava tubes for locations for habitats on the moon and Mars. And some of those you see up on the screen. Obviously, a reduction in radiation exposure would be one. The idea that we could also move into a lava tube in the event of a dust storm, not only for the habitat, not only for the inhabitants themselves, but also the equipment. You can imagine what a long-term dust storm would do to the type of equipment that would be on the surface if that's where your facility was at. There's also the concept that within subterranean areas, you have a less wide change in temperatures. That's true pretty much in any type of cave, natural cave, or lava tube environment. Also, as you have seen during a number of the other presentations that have been here over the last few days, there's a much more focus on taking a look at the potential for searching for life in subterranean environments and also search for water. Now, obviously, if that's one of your goals and you have access to a cave system of some sort that's nearby, that allows you a potential opportunity to take and combine those, where basically your facility would be in a location that's very close to the areas that you would be exploring. But the real issue, the real concept here is basically a reduction in the mass and volume associated with lifting everything you need to live on another planet off the surface of Earth into orbit and then onto the location of wherever your facility should be. Now that said, you have to have the lava tubes out there. They have to be prolific enough to there and in locations where you would think that they could serve that purpose. But when we first started our look at this about a decade ago, there was very little information on what was out there. But as time progressed, basically what happened was more and more information came in to demonstrate that there is really a potential for these types of configurations for lava tubes and subsurface caves to be in locations that we might consider using for this purpose. So what we're looking at potentially at this point in time is one potential alternative among many that we can take a look at relative to putting in habitats and facilities both on the moon and on Mars. That said, there is one issue from our point of view, ours meaning the guys out in the field, that really rings some alarm bells for us. And that's what this slide demonstrates here. That is, to this point in time, the facilities, at least the ones I've been involved with, that have been established in the Arctic and the Antarctic, and those in sub-mariner locations, underwater habitats, not a single one of those has ever been designed or conceived for the purpose of eventually carrying forward onto creating a self-sustained community. Our last speaker explained a lot of reasons why in the Antarctic Treaty that would be the case. But basically what we are saying is, okay guys, let's step back and take a look here for a minute. We know we want to go to the moon and establish a facility. We know that we want to go to Mars and establish a facility. But the reality is, even though we're pretty good at putting bases at the South Pole and and flying in LC-130s to resupply it. We have no experience at then taking a remote or hazardous environment location and turning it eventually into a self-sustaining or complex of some sort. Well, let's step back a little bit. We know that any objective, anything that we want to accomplish, the human species usually takes 3 types of process approaches to. We only really do 3 things when we're doing anything, be it buying vegetables at the store for dinner or going to Mars. Those 3 processes are simply solving problems, making decisions, and implementing plans. In my world, a problem has a very specific definition: deviation of actual, or should, or cause is unknown, and it's of concern. When I step out of a habitat somewhere in the Antarctic and get into a snowcat and turn the key and it doesn't start, I have deviation of actual from should. That sucker should be starting and it's not. I don't know why it's not starting, and it's of concern to me because I need that, excuse me, I need that snowcat for a specific purpose. All right, well, there's 2 things I can do about that, and that's the same in pretty much any kind of program. And that is, I can either find the cause and correct it, in which case it completely goes away, or I can adapt to it. And adaptation means that if the battery's dead and the next battery is 2,000 miles away at true value in Punta Arenas, Chile, excuse me, I'm going to have a bit of a problem, so I am going to have to adapt to the situation. Well, the same basically holds true with any kind of human type of effort that we take. Example is with decisions. We have an object and an action in a decision. I get a new job. I want to buy a car to get to the new place. Well, what have I just done? I've said basically I have an object and an action. I want to buy a car. But what I have really done is I have eliminated a number of potential viable opportunities and alternatives associated with what I'm trying to accomplish. And that's one of the things that's of primary concern to us is how are we going to go about defining actually what we're going to do on Mars? Are we simply saying, well, humans to Mars? Well, there's your objects in action, but there's also expanding that, and that's where viable alternatives come in. We can also say, basically, establish a human presence on another planet. Okay, it's a wider type of objective, but it's the one that basically changes the value system of the different alternatives. Now, why am I talking about this? Well, it's simply because we need to really take a look at what is the end game. What are we trying to do? We've got all these puzzle pieces. We have lots of speakers. We have lots of people all over the world, and they're basically saying different things. They're saying, some of them are saying, we're going to establish a base on Mars. Some are saying, no, should we establish the base first on the moon? And then should it be a long-term established base? Should it be one that basically evolves into a community? So we don't have a real consensus there. So that throws a real monkey wrench from our point of view into which alternative we should look at in relationship to proceeding forward. Well, if you take a look at most of the alternatives that are available for service-type facilities, for temporary facilities, or even for facilities that are eventually going to become self-sustaining, and you filter out all of the basic different alternatives and what you wanted to do and what you needed to do, there's one that seems to pop up over and over, always in the top 2 or 3, and that's lava tubes. Basically, what we're saying is that if we look at and focus on lava tubes for natural cave systems, for locations, for facilities on the moon and Mars, we have basically mitigated to a certain degree whether the end goal ends up being, just putting people on Mars at a facility or putting people on the moon at a facility, because the infrastructure necessary, the engineering, the putting together of all the subparts, the life support systems, the agronomy, all of that basically stays awfully close to the same. There are some deviations. For example, it would be very difficult for us to survey the inside of a lava tube to determine how big to put an inflatable habitat using a drone on the moon. We are looking at, given some of the stuff that JPL is doing, the possibility of playing around with that on Mars. But the reality here is that when we're looking at going off to another location, going off to the moon, going off to Mars, and we have no historical model that allows us to create a transition from a temporary type facility to a permanent type facility anywhere on the planet. We haven't done that yet. So we're stepping back and saying, okay, what's a good way to approach this? What's a good way to look at maybe taking all of these different ideas, all these different concepts, and focusing them into one area, into one regimen? Well, in the past, historically, the way we did this, basically, with facilities in the Antarctic, is we got everybody together. We built basically prototype facilities. We did this for a number of the Asian countries, of which won't be named at this point in time. But in essence, what we did, because they had no experience whatsoever with Antarctic facilities, is we had them build a prototype of what they thought they were going to need in country. They then went through and tested them to a certain degree, and then they put them on ships and they shipped them down to the Antarctic. But before they got to the Antarctic, we took them one more time and put them on a dock and built them through their guys inside to see if they had everything they needed before they were going to winter over for the first time. And sure enough, in almost every case, they did not. So somebody opened the door, went down to the local ferreteria, to the hardware store, got whatever he needed, and came back. So the reality is what we're doing is we're decreasing the potential for having issues associated with risk environments that would otherwise be a real challenge. We contend that that same thing holds true in relationship to how we need to approach looking at habitats, both lunar and Mars. And the reason I keep coming back to the moon is because the moon, in essence, is the dock and Punta Arenas, Chile, and Antarctica is Mars. From our standpoint, we don't put subsurface facilities 6,000 feet below the surface of the ocean the first time. We put them in 30 feet of water off of Key Largo and see what happens and see what we need to do in order to take the next step. And in addition to that, because with using lava tubes, we're in a situation where we can then take and use almost all of those same systems, those subsystems, all in one place again. It gives us a much higher probability of basically being successful at what we're doing. I'd like each of you to remember 4 words here. It's really interesting because a couple of months ago, one of our geologists did a slide presentation at Lava Beds National Monument in California. And it was done on basically the concepts and foundations from the science side, from the geology side, not from the applications and general systems side, which is my bailiwick. And that is on YouTube. And if you just remember the words cave, man, Mars, 4th planet, you can access that video. It's a little longer than this presentation, but it is really kind of eye-opening in what we're attempting to do and how we're attempting to do it. Martin Gasser, who is basically the geologist in Switzerland, also works with us in Iceland, who made that presentation, will also be doing the same presentation in Europe at an ESA conference in Berlin in October. So we decided that this seemed like a really good way to go, that the lava tubes provided all kinds of potential advantages, and that the ability to basically come down and focus all of this into one area. With that, we basically selected, I've gotten a 5-minute thing, so I'm going to try to do the Reader's Digest condensed version here a little bit. But we picked a place in Iceland, and that cave system in Iceland that we picked has 3 basic vertical entrances and 3 horizontal entrances. And we also basically have done a number of things in Iceland. We are forming a nonprofit part of our organization. We have basically displays inside of the museum in Husavik, and we have basically a real strong support from the local community. A lot of that was because a lot of the geology training for the astronauts, for the Apollo astronauts, was done in that area. So, in essence, what we're trying to do, and what our goal is, and it's not a goal relative simply to the company, it's a goal relative to having the entire Mars community step back and take a look at where's a focal point we can take all of these various ideas and concepts and everything and bring them into the field and test them. Not as standalone components, which we used to get a lot with subsea habitat stuff, where we did something and say, gee, that's great, that's probably the coolest thing we'll ever put in there, it doesn't fit. So we could bring all of this stuff in, create basically an environment where we can test on Earth, decide, get rid of the politics, decide whose idea is best, who has the resources, and whatever, and eventually create a turnkey facility that could then go, in essence, to the moon, which could then be tested and then taken off into Mars. We have no interest in who has the scooter ships to get you to San Francisco so you can go get the gold. That's basically SpaceX, NASA, ESA, and everybody else's bailiwick. What we're trying to do is coordinate and bring everybody together from the standard idea and concept of taking all of that information and putting it into one kind of working environment, which is lava tubes. We're also looking at other locations. I just finished a 5,500-mile trip across the United States on dirt roads and basically identifying different lava tubes and different locations where we can do the same sort of thing in the United States, predominantly because Iceland is not workable through the entire winter period. So I want to finish with one little story here, actually two. I'm sure you all get this. I get it a lot. But why do we want to go to Mars? Why do we want to spend all this money to go to Mars and take people to Mars? Shouldn't we be fixing Earth? My typical response is, you know, that would be a really, really good question to ask the dinosaurs. You know, I think if they had the opportunity, they might have considered putting some of their species at another location and having a contingency plan. And finally, I want to talk about a little story. It won't take too long here. And that is, back in 1985, I had the wonderful opportunity to lead one of my expeditions to the geographic North Pole that included two unique individuals on it. One of them was Neil Armstrong, the first man on the moon. The other one was Sir Edmund Hillary, the first man to summit Mount Everest. Along with myself, a gentleman named Steve Fawcett, whose name some of you may recognize from solo flying a balloon around the world. Another gentleman by the name of Pat Morrow, who was the first person to climb 7 summits. Also on the trip was Peter Hillary, Sir Edmund Hillary's son. And we had our den mother, a lady by the name of Betty Wolf. And Betty was this crusty old lady who got coffee and did whatever she needed to do. But she came from Arizona. So when she got her kit, and we sent her all the information, everything she needed to survive up on the Arctic Sea, she got a pair of what we call the standard mittens that most people see or recognize. The big red mitten that fits on your hand. It has a little black strap and a little black thing to wipe your nose with. And so Betty got her mittens. And she put them in her bag, and off to the trip we went. Well, it turned out that the people who built her mittens put the right thumb in the left glove and the left thumb in the right glove. So this was Betty the whole trip. And it became on that expedition kind of a high sign for everybody. Hey, Betty, is there any more coffee available? And we all kind of chuckled. Well, at the end of the trip, we're sitting in a place called the Narwhal Hotel in Resolute Bay and in the Northwest Territories of Canada, getting ready to leave. And Ed Hillary and Peter Hillary and I are sitting at the table drinking coffee. And Betty comes in. She slaps a piece of paper down on the table. And she puts a pin there. And she says, Ed, I want you to write a note to the guys that made these gloves for me and tell them they suck. And we chuckled and said, that's great, you know. So Ed picks up the piece of paper and he says, with gloves like this, I could have never made it to the summit of Mount Everest. Signed Sir Edmund Hillary, May 10th, 1985. And we're just having a good time laughing. And Neil Armstrong's coming downstairs from upstairs where the bed areas were, and he said, what are you guys all laughing about? He says, look at this thing that Ed signed for Betty. He says, give me that. And below Ed's thing, he said, with gloves like this, I would have never made it to the moon. Signed, signed Neil Armstrong, May 10th, 1985. The point of the story is that we here are the individuals that are going to be responsible for ensuring that the first guys that get to Mars don't have Betty's gloves. Any questions?
Yeah, any questions? I have the first question here.
Hi. Can lava tubes be located from orbit, or do you have to go down to the surface and poke around?
The vertical entrances we can spot pretty easily. The horizontal, not so much, but there's a very interesting work being done by a gentleman by the name of Dr. Honda at the University of Tokyo, where he is taking a look at some of the imaging and being able to, from there, with the outflows from the lava tubes, extrapolate how large some of the lava tubes on Mars are and where the locations are.
We have another question over here.
Hi, Mike. I have a real quick question. Can you share with us how, or any ideas how you're sealing off these tubes to be airtight? I mean, are you digging in pre-manufacturing parts, or are you actually in situ creating the seals? And you know what I mean? I just think the nooks and crannies.
Yeah, we're actually looking at kind of both. In the lava tube, we have two concepts. One is a normal facility that people will stay in, will be an inflatable a facility to start with. But we're big advocates of contingency plans. So if you have a way basically to seal off both ends of the lava tube, you can slightly pressurize the lava tube. It doesn't have to go up to 14.7 psi in order to create an atmosphere where if you have a failure in the flexible habitat, you can still survive inside the lava tube. One of the things, and one of the reasons we have this particular tube we're using in Iceland is it has a lot of human history. It's had some graffiti in it. It's been beat up a lot. So we're not basically taking a pristine lava tube and destroying it in the process of trying to figure out ways to change the porosity of the lava tube walls with various types of materials and 3D printing with local available materials in order to create an environment where the atmosphere won't bleed once you put it inside. The huge advantage to this, by the way, we were thinking originally was based upon who the explorers are going to be that's in there. But the agronomists came back to us and said, this is really a great idea, because as a community grows, you could move one of those walls farther and farther back to create larger and larger growing areas. And also there's the idea that if water is found in the subterranean area and you pressurize or even slightly pressurize the lava tube, you could change that from a solid state basically to a liquid state. So there's a lot of fun things going on relative to what we're doing, and there's a lot of challenges. And of course, it's not just us, it's a lot of different people. But like I say, what we're trying to do is step back and say, lots of ideas, lots of concepts, lots of different goals and objectives. And one way to polish those up and smooth them out and bring them all into one effort is through the field operations, what we do. So hopefully that somewhat answers your question.
Here's the next question. I got another question.
Yes, thanks for your presentation. I think a question that immediately comes up to me is in terms of location. If you are going to a lava tube, you have to go to where the lava tube is. But especially on the moon, but I think probably also on Mars, that may not be your first choice of location, especially at the moon, at the poles, where there's these peaks of persistent illumination, you've got power, you've got local sources of water, which would reduce your weekly shipment cost. If you can cover habitats, total robotically cover them with regolith, and you get a lot of the benefits of lava tube, why, can you make an argument for why letting nature choose location as opposed to you choosing locations is more favorable?
I think that's a great premise for a conference and meeting with JPL, NASA, us, and some other folks. Because quite honestly, I don't think at this point in time there's been much value set on actually taking a look at, can we find lava tube locations that meet some of the criteria that you just explained, because we really haven't focused a lot on it. So there may be avenues where we can say, okay, what's the weighted value of this? How important is the areas that we're looking at now versus the potential for the lab? And this gets back to, are you building a research facility on the surface, or is your end goal to try to create a sustainable environment for a potential colony? So the answer to your question is everything's going to be a compromise. And how far you have to compromise to get into a lava tube right now, it's not that bad. 10 years ago, I would have said, nah, it's not happening. Right now, it's not that bad. And with additional looks, additional research, it may be even less of a problem.
We got 2 more questions. Just to follow up on the previous question. We found ice, we found glaciers on Mars. It will be relatively easy to dig a hole, melt the water out, and create your own lava tube the size that you exactly want. So have you guys been working on these kind of concepts?
Yes, that's actually an excellent question. Because of the difference in gravity, the size of the lava tubes are different on Mars and the Moon. To what degree, we don't know. But one of the first things that we're going to want to do is we're not probably going to send explorers directly into lava tubes on Mars before we send robotic survey systems. And one of the things we're working on right now is what's the best way to survey a lava tube? A lot of people come back to us and say, wow, I look at that picture, I look down through the vertical entrance to the lava tube and there's a bunch of rocks there. Well, yes, there are, because that's where the top caved in. But once you get down into the lava tube, they, in most instances, tend to smooth out. And so outside of this arena, outside of the Mars Society, Mars interest area, there's groups of people like the folks that we were dealing with in Lava Beds National Monument that are starting to address those questions. So here's the interesting deal. That question would not have come up if the rest of this had started to look promising. And now that question is coming up, and we're going to start looking at the answers to it.
Hey, one last question?
Yes. There is a historical model for your example. They're called Neanderthals, and they were made extinct by a mobile and inventive surface-living population. How does that work?
I don't know. But you know what? I'm probably going to think about it in the shower tonight a lot.
All right, let's do it.
Thank you.
Move on to